All right, let's take a look at example number 6. Verify the identity. Now in this case, it looks like it printed weird. So let's add the rest of the problem. That is interesting. So there should be a +1 in the numerator on that right-hand side. Not sure what happened there. Okay, so let's take a look at the problem. All right, so the first thing I'm going to do is, well, first of all, the left-hand side looks a little bit more complicated to me. So we're going to work the left-hand side and see what happens. So again, we have secant theta minus 1 in the denominator. And so I'm going to multiply by the conjugate, which is secant theta plus 1. So that way, hopefully, I can get a Pythagorean identity, which I will. But anyway, so the next thing we're going to do is we're going to distribute our sine theta. Actually, no, we're not. We are going to just do the multiplication there. So we get secant theta plus 1. And there's a reason I'm not distributing that yet. I was going to, but then I realized, and you'll see in just a minute. When we multiply the denominator through, we end up with secant squared theta minus 1, which, when you look at the Pythagorean identities, that is actually tangent squared, okay? So we have secant theta plus 1 in the numerator times sine of theta times tangent squared of theta all over tangent squared of theta. And that's why I did not distribute that, because now, since the numerator is multiplying 3 terms, we can cancel out that tangent squared. Okay, so then we can distribute that sine, and I'm also going to turn secant into 1 over cosine. So then that becomes sine theta times 1 over cosine theta plus sine theta. Okay? And then we end up with sine over cosine, which is actually the same thing as tangent of theta, plus sine of theta. Now that's pretty simplified. It's not quite the other side yet. So let's take a look at the other side. Notice I didn't do both sides at the same time, but now I'm going to try working through the right-hand side to see if I can manipulate that a little. So I'm going to break apart my numerator to make that cosine of theta over cotangent of theta plus 1 over cotangent of theta. Ooh, that's looking good, because on my left-hand side I have a tangent of theta, and on my right-hand side I have a 1 over cotangent of theta, and that is the same thing. So that's a good thing. And then I'm going to change this cosine of theta. Well, I'm going to change the cotangent of theta in the denominator. Since it's in the denominator, to bring it up, it just becomes tangent, because remember, those are reciprocals, right? And then we have plus tangent here. Okay, so that's good. And then if I do cosine of theta times tangent of theta, remember that tangent of theta is sine over cosine. So then what's going to happen with those cosines? Ooh, they're going to cancel. Yay. All right, so then I end up with sine of theta plus tangent of theta, which is what I have on the left-hand side. Go us. Good job. So you can work both sides, but not simultaneously, not at the same time. You can work them separately, and then if you can get them to be the same, then you have verified your identity. Okay, let's take a look at example number 7. And there is a typo on this one as well. That sine cubed should actually be squared. Not sure how that happened. All right, so to me it looks like the right-hand side is a little bit more complex, so we're going to work on that side first. All right, so the first thing I'm going to do is factor out a cosine. And then cosine of x divided by cosine of x is just 1. And then negative cosine of x times sine squared of x divided by cosine of x is sine squared of x. Oh, that looks nice. That looks like a Pythagorean identity. So we've got cosine of x times cosine squared of x. And when you multiply those together, you end up with 3 of those. So cosine cubed. That's a really ugly 3, but you know what it is. Cosine cubed. And there we go. We got what was on the left-hand side. Yay! All right, let's take a look at the next one. Again, that right-hand side is looking a little more complex to me, so we're going to work that side. Now, the first thing I'm going to do is that sine to the 4th of x minus sine to the 6th of x. We could actually factor out a sine squared there. So let's go ahead and do that. So we have sine squared of x, and then that becomes sine squared of x minus sine to the 4th. Oh, no, I don't want to do that. I want to take out 4 of those guys. All right, let's take out 4 of them, not sine squared. I don't know what I was thinking. So we'll pull out the sine to the 4th of x. So then when we divide that first one, we get a 1. And then when we divide the second one, we get sine squared of x. And oh, look at that. That's looking like a Pythagorean identity. And then we still have that cosine of x on the right-hand side. All right, so we got that Pythagorean identity right here. So we're going to turn that guy into cosine squared of x. Way to go. And then we have sine to the 4th of x, which is what we're trying to get anyway, so that's good. And we got cosine of x, and we got 3 of those, so we're going to end up with sine to the 4th of x times cosine to the 3rd of x, and that is what we were looking for. So, yay. Okay, so that's how you can verify identities. You work one side of the equal sign at a time. Sometimes you might have to use both, just like we did on number 6, but not at the same time. And you're really just taking those fundamental identities that we worked on and seeing what you can substitute, how can you manipulate each expression to try to get them to equal one another.